So probably we shall start. Let me again introduce you Momjian, who is actually member of core team and actually the head of core team of PostgreSQL, and he's our frequent guest, and thank you, Bruce, for that. And this talk will be about what is actually coming up in Postgres. And let us start.
Thank you, everybody. It's great to be here again. I said yesterday I always enjoy coming to Russia. I think this is my 6th time, and Russia's always been a special place for me. Ever since Fyodor Sigayev took me to his dacha, I love the country. So, yeah, my name is Bruce Momjian. I work for Enterprise DB. I'm one of the core team members. I'm going to be talking about the features of Postgres 9.5. Postgres 9.5 obviously is one of our major releases. Those happen roughly every year. And we're very excited about this release. There is a long list of very exciting features. And I'm going to cover just 10 of them. So I'm only going to talk about the 10 features that I think are the most interesting in Postgres 9.5. And obviously, having worked with the community over the year to develop these features, I have a lot of history of understanding how they were developed, and I'm planning to talk about that. In addition, the organizers asked me to make a specific focus on some of the internals of the features, how we develop them, some of the complexities that were involved, and I'll be glad to do that as well. Because we're going through 10 items, each time I go through an item, at the end of the item I'll stop to ask for questions. So if anybody has a question about that particular feature, I'll be glad to answer that for you. Any questions before we get started? Okay. Let's talk about what I think is the #1 feature in Postgres 9.5, and it is upsert, or insert on conflict. And I will tell you that I think when you look at that slide, you think that is the most simplistic feature that we should have had years ago. This has been probably the most requested feature that we've been lacking for the past couple of years. So we're very excited to have it. But I'll also say that when you look at the feature and when I explain the feature, you'll be, well, why did it take you 19 years to develop a feature that looks so easy to design? All right? So I've often had that question in my mind, so I'm going to try and answer it for people. Basically, when you are developing software, people are telling you what features they want all the time. Whether you like it or not, they're telling you when you're having coffee or tea or relaxing, they'll be like, they get you sort of in the corner and they say, you need to develop this feature. This is a problem. And this is, again, probably the most requested one over the past couple of years. And I will also say that years ago, when people would ask me, I'd be like, I don't know why we haven't developed it either. It seems so simple. I don't know why somebody just doesn't go out and develop it. But once I explain it to you, I think it'll make more sense. So let's talk about what the feature does. How many people are familiar with kind of what the feature does? Anybody? A lot of people. Okay, so for those who don't, let me just go over it, and then I'm going to explain some of the complexities of it, because it's much more complicated than it looks initially. So here's the feature. What it basically does is when you create a table that has a primary key or some kind of unique check, for example, and you insert a single constant into it, and then you try and insert another constant into it, you're going to get an error. Okay? That's pretty standard. That's what That's what it's designed to do. Okay? So without this feature, basically, there's no way, like for example, let's suppose I say, okay, if this feature already exists, I want to put a different number in there. Like, if there's already a 1, I want to make it a 2. It's something very simple. Okay? So there's a lot of applications that need to do what we call upsert, which means insert, and if that fails, update. That's really the kind of the concept. It's like a combined insert and update together, and that's why some of the databases call it upsert, because it's the up from update and the cert from insert. So it's upsert, right? We don't call it upsert, but that's why it's called that. Very common feature, really necessary when you're writing applications. If this customer exists, add them. If this customer does exist, then update some information about them. Very, very typical. And there were all sorts of ways to get around this, but it was very awkward. Very awkward. You have to go through a loop, and if the insert failed, then try the update. And in fact, you just had to kind of loop around over and over again, and it was just a terrible system. So the idea with this feature is that you have a new clause now called onConflict. Okay? So you do insert into table and then your value. And here's one option. You can say if the row exists, just ignore it. Don't throw an error, just ignore it. Okay? So what I'm basically doing in this case is I'm saying if the row already exists and it's going to cause a conflict, then just ignore it. And the reason you don't want an error is maybe you're in a transaction block, you don't want to throw an error. So yeah, this is a very safe kind of case. But the second one is a lot more interesting. Insert into the table, if the value 1 exists, okay, then make it 2, for example, something very simple. Okay, so it's a 1, make it a 2. And what I'm doing here is this is the combination. This is the insert, this is the update. And it's one single command, and it's happening together. So in this case, when it's finally done, you get a 2. So it did the insert and update together. Okay? But let me give you a little more complicated example here. This will make more sense, like it's more typical for an application. So you say create table customer, and you create a primary key, okay, and a name column. And then you insert into the customer table a record, 100, and the name of the customer is big customer, whatever. Okay? Now, if you try and insert a new name for the existing customer, you're going to get an error because there already is 100 in that table, right? So we've already got an error. We've already got 100. And I can't just insert a new name for that customer, but I don't know if the customer might exist, might not exist. So what I really need is this new clause. So I say, insert into the customer this new name and new customer. But if the customer already exists, then change the name. So you can see how it's an insert and an update. If the customer doesn't exist, insert it. If the customer does exist, then do an update. And there's a special clause here, a special specification, where I'm actually specifying the word excluded. And excluded references a column. It references this row right here that was excluded from the insert. So when I say excluded in this clause, I'm actually saying I've excluded that particular name there, okay? So I've got insert into customer, and here's I'm telling it on conflict. If that index conflicts, then I want to change the name. And what happens is that the customer, which originally was big customer, is now changed to little non-paying customer. So a terrible thing happened to our customer. That's, I think, a pretty typical example of why you would use this. There are some other cool things you can do with this, and And it's not just, I'm showing you here a single row that gets updated, okay, but there's more. How many people have heard of the merge command in SQL? Okay, got a couple people, probably 7. So the merge command is really designed to merge one table with another table. So it kind of brings them together like that. Okay, it kind of takes the one and merges it into the other. Now, the complexity of the merge command is there might be some rows that are the same in both tables, right? Because if it was just a question of adding one table to another and there were no conflicts, you could just do insert select and just bring all the rows over, right? That's not a problem. We can do that in Postgres 9.5. We just take all the rows we insert into, and then we just select the other table and right in, okay? But the merge command is designed to not only bring the two tables together, but to manage conflicting rows that might be the same in the two or similar in the two. For example, if I had a customer 100 in one table and a customer 100 in another table, and I want to bring those rows together, how do I do that, right? And how do I specify how that merge is going to happen? And this is going to help us. So I'm basically creating a table here, a new table called merge. I could have called it anything. And I'm inserting 3 rows. I'm inserting a 1, a 3, and a 5. Okay, so 3 rows, 1, 3, and 5. And then I try and do a merge. I say insert into new table, select star from, and I just go 1 to 5. So I'm trying to bring, remember I'm trying to do that insert into select, and I'm trying to take, I've got 1, 3, and 5, and I'm trying to take 1, 2, 3, 4, 5 and merge them in. Okay, it doesn't work because I get an error, because I've got a conflict, because there's already a 1 here, and I'm bringing another 1 in, and the program is going to say, no, you can't do that. However, with our new command, we can do that easily. So here's one example: insert into table select, and I add my new clause. I say on conflict, do nothing. Throw it away. Okay? And what happens is that the original 1, 3, and 5 added to that now is 2 and 4. You see how that happened? Back here, I got a conflict. It couldn't. There's a primary key. It wouldn't allow me to have 2 1s in the table. But because I said, when there's a conflict, don't do anything, skip it, it maintained the original 3 rows, and then it just added the 2 other rows that were not conflicted. But there's more. This case, I'm actually going to not only merge the rows together, but I'm going to do something special for the conflicting ones. So here I have a same case. I'm adding 1, 3, and 5 into the table. Okay? But I'm also having a name field, old, old, and old. So just 1, 3, and 5, old, old, and old. And now I do an insert into my table, my new table, select star, and I'm going to mark new for the values 2 to 5. I'm not going 1 to 5, I'm going 2 to 5, for whatever reason. Okay? But I also say if there's a conflict, then update the status and say it was a conflict. You can see this is getting pretty complicated. Okay? So what I'm saying is the new rows that I'm adding with the insert, their status field is new, and the ones that are conflicting that I'm going to update, and I'm going to make their name conflict. And the result I get here is at the bottom. I have the original rows 1, 3, and 5. Okay, 1 was not conflicting because remember I started 2, right? 2 and 4 are brand new rows, so it has the new from this clause right here, okay? And the 3 and the 5 were conflicting, and it takes the conflict and it adds that right there, okay? The reason, I told you at the beginning, this looks like a really simple command, but it really is not. The reason it's not is because you're always, this command has to work if two people are doing inserts at the same time. So if I'm trying to insert a row that doesn't exist, and somebody else is trying to insert a row that doesn't exist, both of them have to work. One of them has to do the insert, the other one has to do the update. And getting all of that logic to work cleanly with concurrent insert, update kind of switching is very hard. In addition, deciding on a syntax that was very clear is very hard, because as you can see now, it's very clear when you say on conflict, and it's very clear to understand what it's going to do. But this syntax is not part of the SQL standard. So we had to kind of make a syntax that was very clear and very predictable. And also one that would work with concurrent updates and concurrent operations. So for example, the merge command, which you might have used with other databases, doesn't handle concurrency at all. If you do two merges into a table at the same time, you'll get all sorts of errors. It'll say conflict violation or whatever. It'll concurrent violation because the merge as defined by the SQL standard is not designed to be concurrency safe. It assumes one merge at a time. This command, the reason this is better than merge is that it's actually designed to allow multiple concurrent operations at the same time. Very complicated, very big patch. Took a huge amount of effort to get it finished and committed, and a lot of pushing and sort of helping. Heikki, you were intimately involved in this, maybe more than you wanted, right? You want to say something, because I got a chance to freely talk here. So.
Nice. Yeah, it was a complicated feature, as you said. It's getting the concurrency right. That was really hard. I was mostly involved with that, getting the logging correct, but there was other people working on getting the syntax, manageable, and that was at least as much work. But yeah, I'm glad we had it finally. It was a lot of work.
I know.
And it took a long time. It took a long time just to review it and argue about all these things.
Yeah, at the time we weren't sure we were going to get it. It looked like it was just a very painful process. I don't know why this one particularly, but the thing that, and unfortunately I thought I had a URL here, but I don't. Yeah, right, I'm sorry, here it is. This is the URL I wanted. I thought this was a trivial feature, and I thought there was something wrong that we couldn't fix it right away. We couldn't get it right away. And last year I went to this talk. If you download that PDF right here. By the way, these slides are all on my website, so if you want to download this presentation, feel free. It's right there. But I sat in this. I mean, just look at the title. Upsert Weird is the name of the presentation. And walking out of that presentation, I was like, oh, this is so bizarre. This is a really, really hard thing. So if you think this is real easy, this is really where you want to go to learn why it's different. Again, it's different than merge. It's row-oriented. It handles concurrency properly. It has a very nice syntax that I think is very predictable. And as Heikki said, it took a long time just to get the syntax agreed to. So, any questions about this feature before I go to the next one? Yes, this gentleman in the back is first. Yes.
One question about the cost of this feature. In a term of logging, let's we insert 1,000 records without on conflict, and on conflict do nothing. It is equal. Yeah.
So the question is, if you're inserting 1,000 records, what's the overhead of that? Heikki, we didn't really measure a huge amount of overhead in this, did we?
I don't know if anyone ran any benchmarks, actually, I don't remember. But it should be about this. It shouldn't be much slower than regular insert.
Yeah, it shouldn't be much.
It does one index scan to check if the row exists before, and then it does the actual insert. So there is some overhead. If there is actually conflicts and concurrency, then it's going to be slower because mini rollbacks within the command and all that stuff. But that's assuming that there aren't conflicts, it should be about the same as regular user.
Yeah, so in summary, it should be, if there's no conflicts, it should be about the same as a normal insert.
Yeah.
And if there are conflicts, then there is going to be some retries as we continue to try and get a lock on the index to add our row. So, you know, it's going to be a little more overhead if you have conflicting operations happening at the same time. But, you know.
Another one.
Yeah.
When we insert the same 1,000 records, the cost of blocking equals of only quantity of conflicting records, not total inserted record.
Right. I think the only overhead you're going to measure is the number of conflicting rows, not the total size of the insert. I think that's what you're, yeah. Am I right there, Nikki?
I didn't understand the question.
He was basically saying, if I get 1,000 rows and I have like 2 conflicts, is it like 1,000 conflicts or?
Yeah, it's per conflict.
It's per conflict. Yeah, it's not per row.
Right. If you have a conflict every now and then,
it's not. Yeah, random conflicts is not going to be a big deal. Small number of conflicts is not a big deal. I see what you're saying is the whole transaction affected. No, it's per row of conflict. You're going to get the overhead one. I'm sorry. Yes.
The question is how this feature relates with different constraints. I mean, if we observe multiple rows in the single statement and we have a foreign key constraint on the same table between different columns, and if we insert values in opposite direction, I mean, the first inserted row refers to the very last row that would be inserted in the very end. Can this be handled by this operator or not?
Did you understand that question, Nathan?
Not sure. We didn't do anything about foreign key constraints, let's put it that way. This is just for you.
Yeah, but it's not going to affect, foreign key constraints are not affected by this because either you're inserting the row and the foreign key couldn't exist because you
So the question is, can I please retry?
it doesn't recheck the foreign key constraints because of the
So, I mean,
anything way.
you can observe multiple rows in a single statement, right?
Right.
And basically that means the result will differ based on the order of the rows you give to the statement, right or not?
If you have two of these commands running at the same time.
No, a single session, single command, multiple rows. I get different results based on the order of input rows. True or false?
I don't think so.
So how to get it, provided we have a foreign key that tells us the row must have a parent value, right? And if the first entry tries to refer the ID that would be inserted at the very last row,
okay.
we need somehow to defer the value.
So if you have a foreign key that references the same table.
Yeah, exactly.
Oh boy.
Yeah, you're right. It's gonna make a difference in what order you're inserting. Yes. So you should insert the parent first. It's true. Yeah.
So will it play? I mean, will it blend? So will it work together, absorting and defer key constraints?
Yeah, it works together. But there isn't nothing to handle conflicts on the foreign key reference itself. But it will handle. You try to insert the same primary key, and you also have a foreign key on that. And as Olav said, you can mark the foreign key reference as deferred, and that means that it's only going to check the foreign key constraint at the end of the transaction. And by that time, you already inserted all the rows. So that.
Another question. Let's suppose we have merged two tables, as we see in the presentation, and we have two transactions that updates the same row. What the value of this row will be?
So you're doing this, and somebody's doing an update at the same time. That was the question, I think, right? Yeah, if we were going to be challenged on this anywhere, if this is the country we're going to get no challenge on. So the question is, you're doing this merge type of operation, and you're doing an update at the same time, then effectively, if the update gets there first, the update will fail. I mean, it won't find any rows, and if it gets there second, then it'll do the update. So it's the same laws as a normal insert. In other words, if the row didn't exist, then you do an update, the update doesn't do anything. If the row does exist, then you see it. But it's the same rules you have for standard update. I don't see it's any different for upsert at all for this command. I'm gonna have to move to the next feature. We can come back to this, but I want to make sure I get through the feature list. And again, it's really interesting questions, but I'm a little worried about the time. So the second feature that I think is great is something called block range indexes. And the reason these are great, yeah.
I have another question about the first feature.
No, we're done. We can't take it. Sorry. No, I'm sorry. If we have time at the end, I'll be glad to answer. Heikki will be glad to answer your question. Sure. That's right there, yes. Because I think it is a very, very interesting. Obviously, you understand the complexity of the feature. This group understands why this was so hard. I think. I
encourage everyone to test this.
Yeah.
Right now.
It does it now.
Released like five.
You have a couple months, but yeah.
Let's find the bug.
Let's work on that. Yeah, very good. Thank you. This block range index and Alvaro, you here? There he is. Great. Okay. So Alvaro Herrera developed this feature. It basically is what I would think of as like a mini index. I think the real win of this is that the index is, the index is 0.0, its typical index is 0.003% the size of the table. Now, a typical B tree is usually, at least in this example here, is actually about 60% the size of the table. Okay? But the Brin index, the block range index, is, again, 0.003, tiny, very small, certainly easier, uses very little memory. There's less update overhead because, of course, there's just not as much data stored in there. What it basically does is it stores the minimum and maximum values for a range of blocks. So normally B-tree would still have a record for every single row in the table, right? Hash will have a, normally most indexes have a record for every single row in the table. What this does is it has one entry for a megabyte of data in the table. By default, it can be, you can make it smaller or bigger, but by default, it's going to be a megabyte of data, one index record. And this allows you to do things like just put an index on every column. Because again, the index is so small, there's not a lot of overhead. It's ideal, I think, for naturally ordered tables, things like insert-only tables that by their definition are chronological or batch-loaded records, because in that case, the index is going to point to your records very quickly. It's designed for very large tables, okay, which would normally have very large indexes. But because of the design of the system, this is a very small index and normally will fit in memory and be very, very efficient. Can we give the microphone to Alvaro? Do you want to say anything about this feature? Because I rarely get the authors in my talk. So. Thanks.
You're saying there that the lookups are slower than B3. This is not actually true in all cases. We had
someone at second pattern tested with a query that scans a large portion of the table.
Yes.
And it was faster with a green index than a D3, so that's a win as well.
That's deep. Great. Yeah, I was basing that on a blog post that somebody did. Well, I guess a different data set of some type. Yeah, let's take a question there.
And the question is, does this feature plays with the index-only scans? I mean, can we put a green index over, say, a regular B3 index to scan just a subset of the values?
No, it's not going to work on index-only scans because there's not a data row for every, there's not an index row for every data row, so it would never be possible, I think, to do index-only scans with this. But again, this is an area where Postgres typically is not done well. Really large tables, sort of data warehouse type of workloads, indexing every column. This is a game changer, I think, in what you can do with Postgres in the data warehousing space. Any other questions about this? Okay. So this is an example, basically creating a B-tree index and a bring index, and again, you can see the size difference there. The third one is, again, really big. Grouping sets, cube, and rollup. This is, again, similar, very popular for data warehousing. These are SQL standard features that we have wanted for a long time. It was developed by a gentleman in the UK called Andrew Girth. And effectively what these commands do, and they're kind of hard to understand, but they effectively allow you to do group by for multiple combinations at the same time. If you've ever tried to do if you ever need to do multiple group bys and get results from a single command, this is for you. So let's look at an example. Here is a employee table that has, let's see, 6 employees. Okay, 2 of them are in San Francisco, 4 of them are in Philadelphia, 3 of them are in sales, 2 of them are in marketing. Okay, so we've got kind of an interesting layout. And again, let's pretend we're doing a data warehouse here. Let's suppose we want to know how many people are in each office and how many people are in each department. Well, we could do it separately. We could say, select group by office and give me the total for the office. Select group by department, give me the total by department. But of course, I'm looking at the data twice. I'm processing the data twice. I have to run 2 separate queries. Now, I could combine the queries together with union all. I could say select group by office, union all, group by department, and I get this result. But this result is not really great. It's not great for 2 reasons. One, it's a single command, so I only had to send 1 command. But the problem is that I had to access the data twice. I had to do a scan of those tables twice. Okay? And also, my result has the marketing departments mixed together with the offices. Right? Kind of awkward. And in fact, look, the title is office because I used office in the first query, and that's the way the labels work. So I used office here and department here, and now I've got them all mixed together. Now I could have added like a little flag and had a D or an O in the first column, and that would tell me whether this is an office or a department. But still, this is not great. I'm having to access the data twice, and my offices and departments are jumbled in the same column. So this is where the grouping set, the roll-up, and the cube really help. Here is an example of a grouping set. I basically have now 1 query, 1 from clause, I'm accessing the table one time, okay? And I've got a new clause here where I can say grouping sets, group by grouping sets, and I can specify more than one grouping arrangement here. So I've got a nice display, again, one access to the table, and I've got my office all in the office column. I've got my departments all in the department column, and the ones that aren't mixing, this is all nulls here, this is all nulls here. So what it's giving me 5 rows. The row that has a non-null in the office, that's the total for office, and the one that has the non-null for department, that's my department total. You can kind of see one query, and I haven't had to split this up. Okay, it's all coming together. All right? However, there's more. There's a new command called rollup. And what rollup does is it allows me to get totals in a hierarchical fashion. And I have to show it to you. It's really hard to explain. But what this does is it groups them into categories. So now I say, how many people in Philadelphia marketing? 2. How many people in Philadelphia sales? 1. How many people in Philadelphia shipping? 1. How many people in Philadelphia total? 4. See down here I have my Philadelphia separate and I have my department separate. It doesn't tell me how many people are in sales in Philadelphia, it just gives me a total. It doesn't break it down. So the roll-up breaks it down. It says, I will break down in a hierarchical manner for each office department combination. I'll give you a total, and then I'll give you a total for the office together grouping. The same thing for sales. How many people in sales in San Francisco? 2. And in fact, in San Francisco, total I have 2. And then I have another row where they're both null, and that's the total number of employees I have. Again, I didn't have this before. This did not exist here. I would have had to add these together, 2 and 4 of these 2. Okay? So that's what rollup does. It actually gives me like a hierarchy. It finds every unique combination of the 2 columns I specify, and then it gives me a total. Every combination of the 2 things, a total, and then at the end it gives me a total for all the rows. And cube goes even farther. So for cube, we again just say cube by office and department. It gives me the same results as rollup. Philadelphia marketing 2, Philadelphia sales 1, Philadelphia shipping 1, Philadelphia 4, right? We had that before. Then San Francisco sales 2, San Francisco total 2. But then it goes through the department and it gives me totals by department. And then it gives me the total for everybody. So what it's doing, it's giving me every combination, right? Of missing, non-missing, whatever. So the roll-up, the cube, and the grouping set are kind of all related. In fact, this cube example can be rewritten with grouping set. Because grouping set is kind of the basis for cube and roll-up. So effectively, when I'm saying cube, I'm really saying grouping set office, grouping set department, which is what we did back here, right? This is what we got right here. And then I'm also saying, give me the office department combinations, right? And then also give me paren, which means just give me the total. Give me the total of everybody. That's where that 6 comes from. Okay? So again, this has been asked for a long time. I think it is going to be very useful for us. A lot of people want it. Any questions on this? Pretty straightforward, I think. Let's move on to a more like complex one. Row level security. Again, a lot of people wanted this one too. You can see I was a little worried that 9.5 wasn't like looking very good feature-wise a couple months ago, and I kind of said, you know, we really need to get upsert in, and we need to get grouping set in, and now it looks really good, I think. Everyone's very proud of 9.5. It's going to be a lot of really great features coming in. Row-level security, obviously very important for people who are concerned about security. It allows you to specify security at the row level instead of at the table level. Yes, we have views and so forth, but there are some security cases where only row-level security will do. Basically, to implement it, it gives you new permissions for select, insert, update, and delete on existing rows with a special using expression. You can add a special check constraint for insert and update as well. And you use basically a generic expression. It can be checking for the concurrent user, for so forth, time comparisons, and we've got some new commands. So let's take a look at what it looks like. First, you have to have row security turned on. Fortunately, it is turned on by default, which is nice. Then I'm going to create a table called orders, and I'm going to do a new command, alter table orders, enable row level security. So I'm basically saying that this table now is participating in row level security, and I'm going to create a policy which says that the orders table only can have insert, update, delete, and select where the entered by column equals the current user. Again, that's pretty vague, but let's look at an example. I create two users, employee 1, employee 2. I set my session to be employee 1, and I insert into employee 1 a fuse, and I insert the current username into that table. Then I set as employee 2, I insert into that username the current user. Okay? Then if I become Postgres and I do a select, I see both rows. But if I become employee 1, I can only see the column that has employee 1 in the entered by field. Remember, that's the specification we did right here. Entered by has to equal current user. So we basically have that being enforced here. And then for employee 2, again, it is enforced for employee 2. Okay? Pretty straightforward. Again, a lot of stuff you can do with this, but you know, I think we're still figuring out how to use it. It's going to be pretty cool. Okay. Next feature, really kind of interesting. Although there's a lot of text here, so I'm going to not be able to cover all the details. But effectively, we have had some very impressive improvements in the way we do sorting of columns. Previously, we used to sort. We have to look at the whole value. Now we have this abbreviated way of doing sorting. We have a use of sort of quick equality checks. We've improved the way we do hashing pretty significantly. We've added inline sorting to some commands. And also, this is kind of an interesting one. Previously, when we were doing accumulators for sum and average, we had to use numeric because some of these totals got very big. We ended up implementing 128-bit integers on many platforms. And that greatly speeded up a lot of the aggregate calculations because you're not having to do it in a numeric data type. You're doing it in a data type the CPU understands, particularly 128-bit integers. So that was a kind of cool feature, I think, in kind of speeding things up. The next one, this one is more about scalability. We've improved the way we handle the shared buffer cache. We did a lot of improvements in the pinning of buffers and the way we do page locks. A lot of improvements in multi-socket systems. And then again, some of the sort of low-level stuff. I was involved in this one, sort of testing to make sure that the buffer descriptors were aligned to the CPU cache lines. It's kind of interesting. But again, hard to really understand. These are very abstract concepts, but you get the idea that Postgres will be much faster for very high concurrency, very high socket count systems. We've always been pretty good, but again, some of it, we were seeing problems on some of the very high socket counts. You're now seeing systems with 128 sockets, 64 sockets. These type of systems are getting to be popular, and we had to kind of handle those. Number 7, the write-ahead log files typically were, the number of write-ahead log files typically were configured by something called checkpoint segments. This was kind of a crude value. Effectively, what would happen in a checkpoint during write-ahead log is if you had a lot of write-ahead log activity between checkpoints, we would keep adding write-ahead log files to the PGX log directory, and you'd never decrease them. They would just keep adding up to the total checkpoint segments, and we never got rid of them. I don't know why we never got rid of them. I guess it was too hard. But again, Heikki was involved.
I mean, surely we did recycle them before as well.
But not as aggressively. Is that what the change was?
No, it just changes the way you tune it.
The way you tune it, right? We would get rid of them if we went. It seems like it's a lot better to be tuned, a lot easier to tune. A lot easier to tune, yeah. Because before it just seemed like if you set a very high checkpoint segments, you'd end up with a really big Xlog directory. And eventually it would kind of go down, but this is a better way of tuning it. You now have min wall size and max wall size.
Yeah, we used to just have the checkpoint segments, which meant it controlled basically all of those things. Now
right. Now you can separate it out. Yeah. Number 8, additional JSON, particularly the ability to change a single field in a JSON document. That's what the JSON set does. You can also now concatenate, like merge documents together. Really kind of interesting, I think. You can also remove elements with a minus sign. So again, continuing to improve the JSON stuff. Foreign data wrappers. This is a little vague. The reason this is so important is not so much the fields that are things that are listed here, but the idea that this is sort of paving the way for perhaps a built-in sharding solution for Postgres using foreign data wrappers. So the idea of having foreign data wrappers that can be part of inheritance, that can be part of check constraints. You can kind of see the idea of foreign data wrappers as being part of partitions, the way we do partitions. This is all kind of building to that kind of conclusion. And then finally, and the good news is I will have time for some questions because I realize I've been sort of shortchanging the question thing. This is my sort of pet favorite feature. I'm not sure it would reach the top of anyone else's list, but how many of you use PostGIS? Any PostGIS? Okay. There's been a kind of an embarrassment to me in the way that Postgres works with PostGIS distance calculations. I don't know how many of you have actually experienced this, but I'm just going to show you what it looks like. Before Postgres 9.5, if you needed to compute distance using an index, the best you could do was to actually do a query and compare it against what we call a bounding box, because we only index bounding boxes in Postgres indexes. So what you would have to do if you wanted the 10 closest two-dimensional objects is you'd have to do a select with a limit that was like bigger, maybe 10 times bigger, like 100, and then you'd have to refilter it by actually computing the distance and then returning that to the user. And if you look at this blog entry right here, this is from 2011 and it talks about this feature, and it's just embarrassing because this number of 100, you don't even know if that's the right number. You hope that the bounding boxes of 100 objects are within the 10 closest objects, but I'm sure I can create cases where they aren't. So it was kind of this case where you just sort of threw up your hands and said, well, I hope that 100 is big enough for me to find the 10 closest entries. And this was really embarrassing. If you're looking for a nice primer on PostGIS, this second URL right here also has a similar type of query. And it was just terrible to watch people have to do this to a database, because we want to have a database that gives accurate results all the time, and there really is no way to get an accurate result using an index all the time using this feature. Alexander Kuratov, who's actually speaking right now upstairs, he got what we call a recheck ability for PostGIS distance, and starting in Postgres 9.5, you can see a URL here and another URL here, where we're actually talking about the fact that now you don't need that awkward 100, limit 100, let's guess if it's big enough type of case. The system will actually figure out and will actually do a recheck until it finds the 10 closest items. And this was big just because I don't have to see that anymore and hope it gives the right answer. We're now getting the right answer all the time. And again, any feature that avoids embarrassment to me is a win. And that gets on my list. So that's why I was excited about it. So the good news is I have 3 minutes for questions. I had promised I was going to ask after every feature, but I didn't. So let's see what questions you have. The gentleman in blue in the back. Thank you.
Question about the first merge.
Yeah.
Is there some way to match not only one primary key, but several columns? And not primary key, just several 2 or 3 columns to match?
Yes.
So, it's too hard to show.
So you can, first of all, you have to have a primary key or a unique index on all of them. But after you do that, you just list them. I think you have an example.
Yes, I did.
Yeah, there you have on conflict X. You can do X, comma, Y, comma, Z. And
X is the name of the column.
Yeah, so
Really nice.
you can list multiple columns there.
Thank you.
Great. Uh-oh, it's going to be bad.
What happens when status is equal conflict will conflict too?
What would happen if...
Action set will conflict too. You see, insert into on conflict update, and this update will conflict again.
Another conflict after update.
The one of the transactions is going to wait for the other to complete.
Yeah, one's going to wait for the... It's like a normal update. So one update will wait for the other update to complete. That new update will see the new version of the row, and then we'll perform the update.
It'll just update it to conflict again with that state.
It would, yeah.
It would do like a update counter.
You'd have more than one conflict. Yeah, you're right. And he's saying you could add like numbers to it. Yeah.
How to handle the situation when multiple rows are matched? During
You mean in the update? The update matches multiple rows?
Only insert.
Oh, you mean it's going to conflict with multiple rows?
It's going to conflict with... It couldn't because you have a...
How to separate this case from matching only one row?
If it's just... So if you have that statement, that's not possible. But it is possible if you specify multiple columns there, because it might conflict on the index on one of them, and another row might conflict on the index on another one. Yeah, that's a good question what happens. I think it's just an arbitrarily...
This is actually a problem with standardized merge command.
Okay.
Thank you.
Yeah, that's a good question. It's probably going to... Yeah, it's probably going to conflict on the, like in the order you list them there, but I wouldn't trust that. Just try to avoid that.
Okay, thank you.
Did I mention Heiki's going to be around later today? Unfortunately, I am out of time. I appreciate being able to present this to you. Again, I'm excited about the 9.5 features. Obviously, everyone's excited about this feature, which is always good to see that we've kind of done the right thing. And obviously, there's a lot of complexity to it, which you also understand. But again, I think we do have some really, really nice features. Again, here's the list. And I'm looking forward to 9.5, probably sometime in September, October, November time frame I think we're looking at. So thank you very much. Appreciate talking to you.
Thank you, Bruce. Друзья, всех прошу не расходиться. У нас прибыл Олег, и буквально через 3-5 минут он приступит к своему, так сказать, обращению. Поэтому оставайтесь в своих местах, мы сейчас уже скоро будем продолжать.